Hello, this is Hosub at Samsung Research America. Today I present our research about discovery and prediction of user-preferred picture settings on smart TVs. Picture quality is the most important value in TV devices, and users can customize picture settings to find the best possible picture quality out of their TVs. However, it might be difficult for some generic users to do so. For these reasons, TV manufacturers provide predefined picture setting configurations such as picture mode. Using picture mode, users can easily change picture setting. We still have some questions. First, how can we better define the picture mode that users are looking for? Next, if we found user-preferred picture settings, what caused users to prefer this setting and how these settings deliver different picture quality compared to default. Lastly, we would like to know whether it is possible to infer and recommend the optimal picture settings for the given user situation. To answer our research questions, we first propose a methodology to discover new user-preferred picture settings by analyzing large-scale smart TV usage log data. Next, we figured out the reasons why some users prefer to have their picture settings rather than the default setting. Lastly, we confirmed the feasibility of predicting people's decisions to choose a specific picture mode out of 4 available options through the deep learning classification model. Here I'll explain a dataset we used in this paper. The dataset is composed of historical picture setting changes made by our customers. This was 4 months' data and was collected from 8.6 million Samsung TVs in the United States. We also checked the number of picture setting changes per individual user. We got to know that about 63% of the users never changed picture settings at all. Only about 34% of the users changed picture setting 1 to 5 times for the data collection period. So we focused on these users and we came up with 79 million records collected from 3.1 million TVs. Now I discuss how we discover new user-preferred picture settings. Here we take the user clustering approach. First, we divide the dataset into 4 picture mode categories. For each picture mode dataset, we then extract a picture vector characterizing its user's picture setting behaviors. Next, we perform k-means clustering on the extracted picture vectors in order to segment users into groups based on the similarity of their picture setting behaviors. Lastly, we extract picture setting configurations that best represent each user group. This is the result. We confirm that each picture mode was clustered into 1 major and 2 or 3 minor modes. As can be seen, a major mode is almost identical to its default mode. But minor mode differ from the default mode. For example, standard 1 is different from the default in terms of brightness, sharpness, and color. The same goes for standard 2 mode but with different picture setting item. So we can assume that different users might have different picture setting preferences. From here, I compare the newly discovered picture mode from various angles. The first one is panel type. We confirm that there exists some picture modes that are more preferred by TVs with QLED panels. For instance, movie to mode users are more likely to use QLED TVs than other movie mode users. The next one is panel size. We also confirm that there exists some picture modes that are more preferred by big screen TV users. For instance, standard 2 and movie 2 mode users are more likely to use TVs in more than 75-inch sizes. The last one is screen resolution. We got to know that there exists some picture modes that are more preferred for 4K content viewing. For instance, standard 2 mode users watched more 4K content than other standard mode users. Now we perform lab experiment to compare the actual picture quality of the default and newfound picture mode. To do so, we perform the picture mode discovery procedure targeted for a specific TV model and evaluate the discovered picture mode in terms of the picture quality realized on TV devices. This is the result. The left side is default and the right side is the newly found picture mode. Movie mode as an example, we confirm the notable difference between the default and the newly discovered picture setting. It seems that users prefer brighter and more colorful feature even when using movie mode. This is our last contribution. Even if we could define user-preferred picture settings from data, users should choose a specific picture mode by themselves. Problem is that most users does nothing to change picture setting, including picture mode. So here we are building a deep learning model that learns the relationships between users' context or habit and their picture mode choices. If we could achieve reasonable predictive performance, we could use the model to recommend the optimal picture mode to genetic users. In our experiment, we achieved the best accuracy of 86% in predicting a specific picture mode choice out of 4 available options. In this paper, we investigate how smart TV users' picture setting behaviors and preferences can be modeled and predicted. We discovered new user-preferred picture settings through the user clustering approach and compared the resulting picture settings with each other from diverse angles. We also show the feasibility of picture mode prediction that can be utilized for recommending picture settings to the user. We also presented some business insight gained from our research in the paper. Thank you for your attention.